The question we are solving now belongs to test series 2. It is of network theory subject. In specific, it belongs to sinusoidal steady-state analysis. As per the question, there is a supply, there is a AC supply of potential Vs volts, and it is given to a transformer to a magnetically coupled coil of inductance L1, and there is another coil which is of inductance L2 and is coupled with the other coil that was shown already. These two coils have a mutual inductance of M. So in this circuit, we need to find the VO measured between the two terminals marked. So, and the dot conventions are as shown. So in this circuit, we need to find VO in terms of Vs. From the given circuit, we see that upon assuming a current of I1 in the primary coil, so we can write that Vs is equal to j omega L1 I1 plus j omega M multiplied by I2. But the current I2 is 0 because the secondary coil has the terminals open. So because of which we can write that I1 is equal to Vs by j omega L1. Also by measuring the terminal voltage V1 at the output terminals of the secondary coils, we see that Vs can be written as minus j omega M multiplied by I1. This is because of the reason that the dot convention is mainly responsible for the sign here, and a current entering the dotted terminal of a coil, which is the case here, produces a voltage which is sensed positive at the dotted terminal of the other coil. So with the polarity shown, the drop would actually be j omega M I1, hence V1 will be equal to minus j omega M I1. So from this we can write that, this is V1. So V1 is equal to minus j omega M multiplied by Vs divided by j omega L1. This is equal to minus MVs divided by L1. From this we can, by applying KVL, we can write that Vs minus V1 minus VO is equal to 0. That implies VO is equal to Vs minus V1. So upon substitution, this can be simplified as Vs multiplied by 1 plus M divided by L1. Hence, the correct option representing the voltage VO is C, because it corresponds to a VO of Vs into 1 plus M divided by L1. Hence, the correct option is C.